Algorithms are just a step-by-step recipe for you to solve a different problem working with your computer's memory. My name is Adi, I'm a software engineer at Amazon, and in this video I'm going to explain how algorithms work in a way I wish it was explained to me. Different algorithms work for different use cases of basically searching for information, sorting information, or manipulating information. But really, they matter when you're working with a lot of data, and they can make a big difference on how fast your program runs when it has a lot of information coming in. For example, let's take search. Say you want to find a piece of information in your memory. Think of your memory as a big warehouse with a bunch of units, and you might have a million units. So you'd have to walk through all million units just to find an item or until you find it. And if it's in literally unit 1 million, you'll have to walk a million like units. Or you can do binary search, which is very similar to how you look for a page in a book. You would, like, if you wanted to find a page, you'd go, like, you don't want to read every page. You'd split it in half and then you'd split it again and then so forth until you find that book, like page number. Next, you have sorting algorithms. You can do bubble sort, which uses a bunch of memory operations, which splits your basically your elements and then compares them over and over again until you have like a perfectly sorted array. Or you can do merge sort, which basically splits your like data into halves over and over again and then does smaller memory operations. And so keep in mind that you're not going to have to like create an algorithm. Mathematicians do that, computer science like researchers do that. Really, you're just going to have to remember as a software engineer that you have to search for algorithms that would best suit your like needs. And you just have to remember time complexity, which is basically how does your algorithm perform when a lot of data is involved. Next, you have graph algorithms, which make graph data make searching through graph data structures easier. So graph data structures store information and everything that they're connected to, like addresses to all of them. Basically, for in that case, you'll have like breadth first search, which is going to like find all your like closest connections and then find those connections closest connections. Or you have depth first search, which is going to take one node, one piece of element, and then it's going to find one connection, and then it's going to go all the way down. So it's like going really deep into your graph or searching your whole graph, and they're good for different use cases. Or you'll have more complex algorithms like Dijkstra that finds the fastest way to get from point A to point B in your graph, which is how Google Maps works. Node A is your home, node B is your work. That they use Dijkstra and a variation of that to find the fastest route. Next, you have dynamic programming, where basically your worker is finding items in your warehouse, but if they know that you're searching for an item that they've already seen doesn't exist in unit 100, they're not going to search unit 100 again. And so it's just remembering information. And so the key is to use the right algorithm for the right job and to remember that like you don't want to overkill and like have a very complex algorithm if you're working with very like little information. That's all there is to an algorithm.